Valerie Cotton used to be Kids First program manager, so it's humbling to have her here and is still being part of the Kids First program. So she's still actively, I'm not gonna let her go too far away. Valerie is the Deputy Director of the Office of Data Science and Sharing at the NIH. And as I said, former program manager at the Kids First. And the areas of interest, she continued involved in the program policy, data sharing, and interoperability. With that, I will pass the word to Valerie.
Awesome. Thank you, Marcia. That's right. Nobody's getting rid of me yet. Can you all see my screen now?
Yes.
Okay. Awesome. So I am so pleased to talk about Kids First Cloud Credits, and this is a new opportunity that we're offering to all researchers. But I'm going to give a lot of background and history and really frame why this is so important to Kids First. So I think you've already seen versions of this slide today. We share it every webinar. You'll probably see it at least one more time, but I wanted to include it just to emphasize this point about fostering collaboration to accelerate pediatric research. And although you've heard a lot about the Kids First sequencing centers and the DRC and the Exo-1 investigators who contribute data sets to Kids First, and these researchers really all serve as the foundation of the Kids First program, but the program is constantly growing, and it's growing through and even beyond the collaborations with these foundational groups. And as we've built out the Kids First ecosystem, I really love that Marcia introduced this idea of an ecosystem, because that's how we've always thought about it. It's always been a key principle for us that this is not a closed consortium, and that we create space and opportunities for additional researchers and community members to benefit from and contribute to Kids First. And we always get the question, how do I join Kids First? And the answer is always, welcome to Kids First. You're in and you're part of this, and anyone can contribute new tools and knowledge as part of this Kids First community, which of course leads to even more collaboration and the enhancement of other researchers' use of the data. And in fact, this was one of the primary motivations for the Kids First R03 for expert-driven small projects to strengthen Gabriella Miller Kids First discovery. So we specifically designed this opportunity, which is still open. I think James will emphasize that applications for the second cycle are due June 10th. And it's really a place where you can contribute your own expertise to improving the Kids First ecosystem that we have built, even if you haven't been funded by Kids First before. And by building the Kids First data resource as a fully cloud-based system, we're really able to realize this principle. We're able to bring multiple tools to the data that live in the cloud, rather than keeping everything in silos or duplicating efforts in local or on-premises environments. And from a researcher's perspective, a cloud-based approach addresses several key bottlenecks that are usually experienced in a local environment. And I also borrowed this slide from our data scholar, Anne Delatmays, and it really highlights the importance of the cloud. But I updated it to essentially reflect that the future is now. Now we're in the cloud, and now we're offering a cloud credit program that is open to all researchers who are using Kids First data, so that more researchers will be able to reap the benefits of the Kids First data resource as a cloud-based system, which means that you get to use a cloud compute platform like Kavatica and community-based standards like standard workflow languages to analyze the data where it lives. And not only is this approach more sustainable for us at NIH, with 48,000 Kids First genomes that are either already released or in the sequencing pipeline, it's becoming essentially impossible to perform this scale of analysis locally. And before I tell you about our new cloud program, I want to share some lessons learned from the internal cloud credit pilots that we've been running internally for the last few years. So these pilots were open to our Exo-1 investigators, and we received some useful feedback, both in terms of positive experiences and also challenges that helped us shape this new program. In terms of some of the benefits, overall, the cloud program helped lower that barrier to entry to using the cloud, especially for those who had never used the cloud before. And because our cloud credits are allocated through the NIH STRIDES program and then dispersed through billing groups that are managed through the 7 Bridges software, we're able to be quick and agile in approving and allocating credits for a given researcher for a proposed project. So administratively, it takes us typically 4 weeks on the NIH working group side to review and approve a request, and it takes a matter of minutes to establish the billing group and a Kvatica after that, which of course is much quicker than the life of a typical grant cycle. The credits also provided a little bit of a safety net, giving a researcher the flexibility to get comfortable using the cloud and specifically the Kvatica platform without dipping into other resources. The cloud credits were often sufficient to help researchers generate preliminary results that could result in strengthening a new grant proposal. And this is actually really the goal here. Use the cloud credits to get comfortable with the environment and plan your next steps for a more robust analysis. And then you can go apply for more funds to continue that work. We heard repeatedly that the scalability of using Kvatica is part of what made the cloud credit pilot so enticing. Some researchers commented that in their local infrastructure, they'd be waiting in long queues. They could only run several jobs at a time. But in Kvatica, you could run dozens of jobs at a time. You can even configure it so that once one set of jobs finishes, automatically you can trigger the next job. And this really helps you do that really large scale analysis. An extremely valuable outcome is that several researchers use their cloud credits not only to take advantage of existing workflows and pipelines that are already available, but also to build new pipelines that could then be containerized and shared back out to the public for other researchers to use and adapt for their research. You might remember Owen Hershey, who is part of Sharon Plon's EXO-1 team studying cancer susceptibility, did precisely that. And we had him talk about it this was his structural variation analysis during the 2020 Kids First Fall webinar. So if you'd like to go back and watch that webinar, you can see Owen talk about his approach. He also more recently presented at the NIH Cloud Platforms Interoperability Workshop this past fall, where he described how he is expanding his work to long-read structural variant analysis across multiple platforms using multiple workflow standards. So Owen really is a great example of what the value of these credits could be. Several researchers also took advantage of the ability to collaborate across multiple parties to co-analyze multiple data sets. But honestly, this was also identified as somewhat of a challenge because the security and governance features of the Kids First data resource, for example, making sure that you have the right dbGaP approvals in place across multiple institutions, if there's a lot of researchers collaborating together, needs to be well established because Kvatica and the Kids First data resource know what the permissions are. They know when you should or should not have access to a given dbGaP data access request. And we'll talk a little bit about how we address some of this later. And as Marcia mentioned, and last year we were able to announce that the NIH Cloud Platforms Interoperability Collaboration has successfully demonstrated that researchers can now co-analyze Kids First data with data from Biodata Catalyst, Anvil, and the Cancer Research Data Commons. And you can do this all in one analysis environment. So this is a Kvatica-centric point of view. A user chose to start their analysis in Kvatica, and Kvatica knows how to enable the researcher to bring together these multiple data sets. Oops, sorry. And to get you thinking creatively about the types of projects that you could do with your cloud credits, I want to tell you a bit about an interoperability project that we are actively working on. So many of you may be familiar with the Undiagnosed Disease Network. This data set includes over 4,000 genomes, and a large portion of those participants are actually children. And the data are currently available in dbGaP and the Sequence Read archive. And you could use both the Kids First and UDN data sets together. So let's say there was a child represented in the UDN who had phenotypes that are similar to children represented in Kids First. Could you potentially use the Kids First data to better understand the condition from the UDN. And David and Adam, very nicely demonstrated that you have the ability to take the phenotype from the UDN data set and compare it to the phenotypes using the Kids First Data Resource Portal and look. And additionally, what makes this easier is that we both use a similar ontology. We both use human phenotype ontology. So it's easy for a researcher to semantically compare how similar the phenotypes might be. And then we also both use a technology health IT standard called FHIR to enable that phenotypic data to be exchanged across systems. So after you do that phenotypic comparison, you could then pull together genomic data from the UDN data set and the Kids First data resource into one private analysis workspace in Cavatica. And what all the technology terms that you see in the slide are really doing on the back end is it will let you do this without having to duplicate the data, without having to download it. You're just staying in the cloud. And then with your cloud credits, you can use those funds to focus on analyzing the data without having to pay to store it again, for example. So this is not fully launched. I broke my own rule about talking about something that's not done, but I just think it's a really good example of the type of creative project you could propose to cross-analyze Kids First data with other data sets that are or will be interoperable in the system. We also heard about some challenges throughout the cloud credit pilot. And just to go over these briefly, so I just told you about how when you're working in the cloud, you're working in Cavatica, you don't actually have to pay for the storage. But sometimes there are storage costs. So if you're working on an analysis and you're generating output files, or you've chosen to upload files that you have locally into a Cavatica workspace, that does begin to accrue costs. And in our early cloud credit pilots, in some cases, this led to overspending of the billing groups. Now, we've put some rules in place to prevent this from happening moving forward, which was a requirement to be able to move forward. So now if that starts happening, we have the ability to warn you about it and then shut down or delete data that's accrued overspending in an account. We also heard that researchers just sometimes didn't know how to get started, felt really anxious about how much it would cost. We often hear my favorite tool is not yet in the cloud and it needs to be ported there. And we also observed that not all users really fully appreciated this aspect of value and scalability. And this makes sense because we have a lot of data that's available now, but over the years, it took time to get to where we are now, which is that there are more than 20 data sets available, but researchers were often focused on one data set at a time. And that's changing now that so much data is available. So to address these bottlenecks, NIH staff worked with the Kids First DRC. And I just want to make sure, can you all see my browser now? Okay, I'm going to assume yes, there might be a little bit of awesome. Yes, okay. So thank you to the DRC for working with us to create resources to just facilitate that onboarding. Here's how you can get started with working in the cloud. And this is now live in GitHub, and we'll definitely share the link and we'll share all the slides. But just to walk you through this so that it'll be easy for you to get started, there's some introductory information about what the Kids First program is, what the Kids First data resource is, how we're in the cloud and why we're in the cloud and why that's important for you in terms of answering some of the scientific questions that you might be interested in. And David talked about the data sets that are available, and you can even, anytime from your home, you can watch David give a really wonderful overview of how to go from the portal to accessing Kids First data in Cavatica. And that's exactly what the second page is. Walks you step by step with these really nice visualizations about logging into the portal, doing your query in the portal to identify the data set you might be interested in, how to export or access that data, and then of course some information about which data do require that dbGaP approval because they are controlled access, in which you can find in the registered tier. And this information about dbGaP is really important because it gets at what I was talking about earlier. You have to have the right dbGaP data access requests in place in order to do a collaborative analysis across multiple data sets. So this link right here, as well as this video, will walk you through that. We talked a bit about how people just didn't, it's really hard. Where do you begin with estimating what what it might cost to use the cloud. And like I said, you don't have to worry about storage of our data, but you do have to be aware of storage of files throughout the life of your project, because it's inevitable to happen that as you work through your analysis, you're generating data products. And this includes some tips about keeping your workspace clean, so deleting files when you no longer need them so that you're not spending those costs. And then some benchmarks of how much it costs to run some of the standard workflows that the DRC has created. So in most cases, you won't actually have to run these on Kids First data. You might have to run it on another data set if you're doing a combined analysis, but it does give you a feel for the type of workflows and how much they cost. And the team also created this cloud cost estimator. I'm going to go ahead and flip to this demonstration tab to show you how you can use the blank sheet and input what type of analysis you think you're going to do, and use some of the published AWS costs, which are here on the reference tab. These change sometimes. So, David created this based on the numbers that were available that day, but you can also update the spreadsheet yourself, and then it'll automatically compute for you an estimate of what it might take to do the analysis that you're aiming to do. So let me switch back. How to apply for cloud credits. So this is why we're here today. So it's a really simple process. I'll talk a little bit more about how we're going to handle this on the NIH side. But to get started, you basically send an email to the Kids First mailbox. And to get started, we'll ask for a few pieces of information, but then we'll respond with next steps. So we're going to need a little bit more, depending on where you are and what kinds of data sets and analyses you're planning on doing. Managing cloud compute costs, again, some strategies for not overspending, keeping your workspace clean, being aware of how your billing group is being spent. And then typical Kavatica, these have always been available, but we tried to put them all in one place for you to get started. And then, of course, closing out your cloud project. And, again, after you've used cloud credits that have been allocated from NIH, we really encourage you to continue using the cloud, but you might have to commit resources from an NIH grant or somewhere else to do that. So with that, just a summary of what this will look like on the NIH side. So I also have a million people to thank, but I definitely want to thank Wei-Ching Lee, who really spearheaded the development of this process. She's been chairing the review committee, who has overseen the review of the cloud credit pilots for the last several years, and has graciously agreed to continue even as we move forward with opening this to everyone. Generally, the process will be that to get started, you could ask for up to $1,000. If you're also doing a cross data set analysis, so that interoperability use case of co-analyzing data with Anvil or Biodata Catalyst or Cancer Research Data Commons, you describe that and you could be eligible for another $1,000. After that initial work is done, we'll ask you to tell us how it went before you can apply for more credits, but you can apply for up to 5,000 more credits after that initial allocation. And then you could even apply for even more after you share workflows or pipelines. So the kind of work that Owen did with using his credits to fine tune and then build a new pipeline and share that back out with other researchers. We have some administrative procedures in place. If we create billing groups, but they go inactive for 6 months or more, we will shut them down. And we'll also take steps to delete workspaces that are overspending. And then I've said this several times, but you can continue working in the cloud even after the cloud credits have been allocated. So this is my last slide. We will be announcing more broadly that we're essentially open for business, that researchers can apply for cloud credits. But these are the basic first steps. And that is my last slide. Thank you all so much.